What if I told you that the solar system you think you know is hiding secrets so strange they defy everything we thought we understood about space? Picture this, a storm shaped like a perfect hexagon, raging for centuries on a distant planet. Or ice hiding in the scorching heat of a world closest to the sun. These are just a glimpse of the mysteries waiting to be uncovered. Today, we're diving into 25 of the most astonishing secrets hidden in our solar system. From unexplained cosmic events to bizarre planetary phenomena, this journey will take you to places you've never imagined. Each discovery will leave you questioning what else might be lurking in the vast expanse of space. So, buckle up and get ready to explore the unknown. By the end of this video, you'll see our solar system in a whole new light. Let's begin. Now turning to the first of these cosmic mysteries, let's take a closer look at Saturn, the ringed giant of our solar system. At its north pole lies a storm so peculiar it looks like it was drawn with a ruler. This is the hexagon of Saturn, a massive, six-sided vortex that has been spinning for decades, if not centuries. Unlike anything we've seen on Earth or any other planet, this hexagonal storm spans an area larger than our entire planet. Imagine a hurricane so vast it could engulf the United States, but with sides so perfectly geometric it seems almost artificial. What makes this storm even more baffling is how it defies everything we know about weather patterns. On Earth, storms are chaotic, swirling masses of wind and pressure. But Saturn's hexagon is a near-perfect shape, with each side measuring roughly the same length. Scientists have proposed several theories to explain this phenomenon. One leading idea suggests that the hexagon is created by differences in wind speeds at various latitudes, combined with Saturn's rapid rotation. Another theory points to the planet's internal heat and the way it interacts with its atmosphere, creating stable, geometric patterns. To put it into perspective, if a storm like this were to form on Earth, it would be like a hurricane spinning in a perfect square or triangle. It's a reminder that the laws of physics can play out in ways we're only beginning to understand. And while we may never see a hexagonal storm on Earth, Saturn's hexagon serves as a stunning example of how alien and unpredictable the weather can be on other worlds. As we move forward, this is just the beginning of the strange and wonderful secrets our solar system has to offer. Next, we'll explore a world that's both scorching hot and freezing cold at the same time. But more on that soon. Now turning to the next cosmic mystery, let's journey to Mercury, the smallest and closest planet to the Sun. At first glance, Mercury seems like the last place you'd expect to find ice. With daytime temperatures soaring to over 400 degrees Celsius, it's a scorching inferno. But here's the twist: deep within its polar craters, hidden from the sun's relentless heat, lies a surprising amount of ice. How is this possible? The answer lies in Mercury's unique geography. The planet's axis has almost no tilt, meaning its poles are never fully exposed to sunlight. Some craters near the poles are so deep and steep that their floors remain in permanent shadow, creating natural cold traps. These areas can plummet to temperatures as low as -170 degrees Celsius, cold enough to preserve ice for billions of years. This discovery challenges our understanding of planetary environments. How did ice end up on a planet so close to the Sun? Scientists believe that comets and asteroids rich in water may have bombarded Mercury over billions of years. The water vapor released from these impacts could have migrated to the poles, freezing in the shadowed craters. Another theory suggests that hydrogen from the solar wind could have combined with oxygen in Mercury's surface minerals, forming water molecules that eventually froze. The presence of ice on Mercury not only defies expectations but also opens up fascinating possibilities. Could similar conditions exist on other seemingly inhospitable worlds? And what does this mean for the search for life beyond Earth? As we continue to explore the solar system, Mercury's icy secrets remind us that even the most extreme environments can hold surprises. With this mystery in mind, let's move forward to another world where fire and ice collide in the most dramatic way, but more on that soon. Now turning to a world where fire reigns supreme, let's set our sights on Io, one of Jupiter's most fascinating moons. Io is unlike anything else in the solar system. It's the most volcanically active body we've ever discovered. Imagine a place where volcanoes erupt almost constantly, spewing lava hundreds of kilometers into space. This isn't science fiction, it's the reality of Io. What makes Io so explosive? The answer lies in its relationship with Jupiter. Io is caught in a gravitational tug of war between Jupiter and its neighboring moons, Europa and Ganymede. These tidal forces stretch and squeeze Io's interior, generating immense heat. This heat fuels the moon's volcanic activity, creating a surface dotted with hundreds of active volcanoes. Some of these eruptions are so powerful that they can be seen from Earth with powerful telescopes. The volcanic landscape of Io is both mesmerizing and terrifying. Lava flows stretch for miles, and towering plumes of sulfur and sulfur dioxide gas paint the moon in vibrant yellows, reds, and oranges. But beneath this chaotic surface lies a treasure trove of scientific insight. Io serves as a natural laboratory for studying extreme geological processes. By observing its volcanoes, scientists can learn more about the forces that shape not just Io, but other worlds as well. Io's volcanic activity also raises intriguing questions about the potential for life. While the moon itself is far too hostile, its intense heat and chemical-rich environment could provide clues about how geological activity influences habitability elsewhere in the universe. As we continue to explore Io, we're reminded that even the most volatile places can teach us valuable lessons about the cosmos. With Io's fiery spectacle behind us, let's now turn our attention to a moon where liquid flows, but not in the form we're used to. But more on that soon. Now turning to a world where liquid flows in an alien dance, let's explore Titan, Saturn's largest moon and one of the most Earth-like places in the solar system, but with a twist. Titan is the only moon in our solar system with a dense atmosphere, and it's the only place besides Earth where we've found stable bodies of liquid on the surface. But don't expect to find water here. Instead, Titan's lakes and rivers are filled with liquid methane and ethane, creating a landscape that's both familiar and utterly alien. Titan's hydrologic cycle is eerily similar to Earth's, but with methane playing the role of water. Just as water evaporates, forms clouds, and rains on Earth, methane does the same on Titan. The moon experiences methane rain, which fills its lakes and rivers, and even carves valleys and channels into its icy surface. These lakes, some of which are larger than the Great Lakes of North America, are scattered across Titan's polar regions, creating a surreal, mirror-like landscape. But what makes Titan truly fascinating is what this methane cycle means for the possibility of life. While Titan's surface is far too cold for liquid water, the presence of liquid methane and complex organic molecules has scientists wondering if life could exist in a form we've never imagined. Could there be microbes that thrive in methane instead of water? Could Titan's subsurface ocean, hidden beneath its icy crust, harbor life in more familiar conditions? These questions make Titan a prime target for future exploration. As we marvel at Titan's methane lakes, we're reminded that the solar system is full of surprises. From fiery volcanoes to icy rivers, each world offers a unique glimpse into the forces that shape our universe. And as we continue to explore, who knows what other secrets we might uncover. But for now, let's turn our gaze to another enigmatic feature of our solar system, a storm so vast and enduring that it has fascinated astronomers for centuries. But more on that soon. Now turning to a storm that has captured the imagination of astronomers for centuries, let's dive into the mysteries of Jupiter's Great Red Spot. This colossal storm, larger than Earth itself, has been raging for at least 400 years, making it one of the most enduring features in our solar system. But what exactly keeps this massive tempest alive, and why has it persisted for so long? The Great Red Spot is an anticyclonic storm, meaning it rotates in the opposite direction of hurricanes on Earth. It's so vast that it could swallow our planet whole, with winds reaching speeds of up to 430 miles per hour. For centuries, scientists have been fascinated by its longevity, especially since storms on Earth typically dissipate within days or weeks. The secret to its endurance lies in Jupiter's unique atmosphere. Unlike Earth, Jupiter has no solid surface to disrupt the storm's flow, and its fast rotation creates powerful jet streams that feed energy into the Great Red Spot, keeping it alive. But even this ancient storm isn't immune to change. Recent observations suggest that the Great Red Spot is shrinking. Over the past century, it has decreased in size by more than half, and its shape has become more circular. Some scientists believe it could eventually disappear altogether, though others think it might stabilize at a smaller size. What's causing this shrinkage? One theory points to interactions with smaller storms that disrupt its structure, while another suggests changes in Jupiter's atmospheric conditions could be playing a role. The Great Red Spot isn't just a storm, it's a window into the dynamic and chaotic nature of Jupiter's atmosphere. By studying it, scientists hope to learn more about the forces that drive weather on gas giants and how these massive storms evolve over time. As we continue to observe this iconic feature, one thing is certain: the Great Red Spot remains one of the solar system's most captivating mysteries. With this storm still swirling in our minds, let's shift our focus to another icy wonder in the outer solar system, a moon where geysers of water and ice erupt from a hidden ocean beneath its frozen surface. But more on that soon. Now turning to a moon that defies expectations, let's explore the icy wonders of Enceladus, one of Saturn's most intriguing satellites. This small, frozen moon is home to one of the most extraordinary phenomena in the solar system, cryovolcanoes. Unlike the fiery volcanoes we're familiar with on Earth, these icy geysers spew water, ice, and organic compounds into space, creating a spectacle that has captivated scientists and space enthusiasts alike. Enceladus's cryovolcanoes are powered by a hidden ocean beneath its icy crust. This subsurface ocean is kept liquid by the gravitational forces exerted by Saturn, which generate enough heat through tidal friction to prevent the water from freezing solid. The geysers erupt from fractures in the moon's surface known as tiger stripes, sending plumes of material hundreds of miles into space. These plumes contain not just water and ice, but also molecules like methane, ammonia, and even complex organic compounds, ingredients that are essential for life as we know it. The discovery of these geysers has profound implications for the search for extraterrestrial life. Enceladus's subsurface ocean is one of the most promising places in the solar system to look for microbial life. The presence of organic molecules and the energy provided by tidal heating create conditions that could potentially support life, even in the absence of sunlight. Scientists have even proposed missions to Enceladus to sample its plumes directly, searching for signs of biological activity. But what makes Enceladus truly remarkable is how it challenges our understanding of where life can exist. Traditionally, scientists have focused on the habitable zone, the region around a star where temperatures are just right for liquid water. Enceladus, however, lies far outside this zone, proving that life could thrive in unexpected places, powered by the internal heat of a moon rather than the warmth of a star. As we marvel at the icy geysers of Enceladus, we're reminded that the solar system is full of surprises. This tiny moon, with its hidden ocean and potential for life, invites us to rethink what we know about the possibilities of life beyond Earth. And as we continue our journey through the secrets of the solar system, the mysteries only grow deeper. Next, we'll uncover why Uranus spins on its side, a peculiar tilt that sets it apart from every other planet in our cosmic neighborhood. Now turning to one of the most peculiar planets in our solar system, let's investigate the strange case of Uranus and its bizarre tilt. Unlike any other planet, Uranus rotates on its side, with its axis tilted at an extreme angle of about 98 degrees. This means that instead of spinning upright like Earth or Mars, Uranus essentially rolls around the Sun like a giant cosmic ball. This unusual orientation has puzzled scientists for decades, and it raises the question, what caused Uranus to end up this way? The leading theory suggests that Uranus's extreme tilt is the result of a colossal collision in its distant past. Imagine a massive object, perhaps as large as Earth, slamming into Uranus billions of years ago. Such an impact could have knocked the planet onto its side, altering its rotation permanently. This theory is supported by computer simulations, which show that a collision of this magnitude could explain Uranus's current orientation. However, the exact details of this event remain a mystery, as no direct evidence of the impact has been found. This dramatic tilt has profound effects on Uranus's seasons and magnetic field. Because of its sideways rotation, Uranus experiences some of the most extreme seasonal changes in the solar system. Each pole spends about 42 Earth years in continuous sunlight, followed by 42 years of darkness. This creates a unique and harsh environment, with temperatures plummeting during the long, dark winters and rising slightly during the extended summers. These extreme seasons are unlike anything seen on other planets, making Uranus a fascinating subject for study. Adding to the mystery is Uranus's unusual magnetic field. Unlike Earth's magnetic field, which is roughly aligned with its rotational axis, Uranus's magnetic field is tilted and offset from its center. This irregularity is thought to be linked to the planet's sideways rotation and its internal structure, which may include a layer of electrically conductive water and ammonia deep within its atmosphere. The combination of its tilted axis and off-kilter magnetic field makes Uranus one of the most enigmatic planets in our solar system. As we ponder the strange tilt of Uranus, we're reminded of the dynamic and often violent history of our solar system. This planet's peculiar orientation challenges our understanding of planetary formation and evolution, offering a glimpse into the chaotic processes that shape the worlds around us. And as we continue our exploration of the solar system's secrets, the mysteries only grow more intriguing. Next, we'll delve into the glittering hypothesis of diamond rain on Neptune and Uranus, a phenomenon that sounds like science fiction but might just be a reality. Now turning to one of the most dazzling mysteries in our solar system, let's explore the glittering phenomenon of diamond rain on Neptune and Uranus. This idea might sound like something out of a science fiction novel, but scientists believe it could be a real occurrence deep within the atmospheres of these icy giants. The concept of diamond rain stems from the extreme conditions found in the interiors of these planets, where pressures and temperatures reach levels so intense that they can transform carbon into diamonds. To understand how this works, let's take a closer look at the atmospheres of Neptune and Uranus. Both planets are composed primarily of hydrogen and helium, with traces of methane, water, and ammonia. Deep within their atmospheres, the immense pressure millions of times greater than what we experience on Earth compresses these gases into a dense, hot fluid. In this environment, methane molecules, which consist of one carbon atom bonded to 4 hydrogen atoms, break apart under the extreme conditions. The carbon atoms are then released and subjected to such intense pressure that they crystallize into diamonds. These diamonds, heavier than the surrounding material, slowly sink deeper into the planet's interior, creating what scientists describe as a rain of diamonds. The idea of diamond rain was first proposed based on laboratory experiments that recreated the extreme conditions found within these planets. Researchers used high-powered lasers to compress carbon-rich materials, simulating the pressures and temperatures deep inside Neptune and Uranus. In these experiments, they observed the formation of tiny diamond-like structures, providing strong evidence that diamond rain could indeed occur on these distant worlds. This discovery not only adds a touch of cosmic glamour to our understanding of the solar system, but also sheds light on the complex chemistry and physics at work within these enigmatic planets. The implications of diamond rain go beyond its sheer fascination. This phenomenon could help explain some of the unusual properties of Neptune and Uranus, such as their internal heat distribution and magnetic fields. As diamonds sink toward the planet's cores, they release gravitational energy, which may contribute to the planet's internal heat. This process could also influence the behavior of their magnetic fields, which are already known to be irregular and offset from their centers. As we marvel at the idea of diamond rain, we're reminded once again of the incredible diversity and complexity of our solar system. These distant worlds shrouded in mystery continue to surprise us with their hidden wonders. And as we move forward in our exploration, the next secret we uncover might just be as extraordinary as this glittering phenomenon. Next, we'll turn our attention to the mysterious moons of Pluto and the clues they hold about the early solar system. Now turning to the enigmatic world of Pluto and its intriguing moons, we uncover another layer of mystery in our solar system. Pluto, once considered the ninth planet, is now classified as a dwarf planet, but its system of moons continues to captivate scientists and stargazers alike. Among these moons, Charon stands out as the largest and most fascinating, sharing a unique relationship with Pluto that sets it apart from other moon-planet pairs in the solar system. Charon is so massive relative to Pluto that the two bodies orbit a common center of gravity located between them, rather than Charon simply orbiting Pluto. This makes them more like a binary system than a traditional planet and moon. Their gravitational dance has led to some unusual orbital dynamics, including tidal locking, which means both Pluto and Charon always show the same face to each other as they orbit. This close relationship suggests that Charon may have formed from a colossal impact early in Pluto's history, much like how Earth's moon is thought to have formed from a giant collision. But Charon isn't the only moon in Pluto's entourage. Pluto has four smaller moons: Styx, Nix, Kerberos, and Hydra, each with its own peculiarities. These moons orbit in chaotic and irregular patterns, often influenced by the gravitational tug of war between Pluto and Charon. Their unusual orbits hint at a turbulent past, possibly shaped by collisions or gravitational interactions during the early days of the solar system. Studying these moons provides valuable clues about the conditions and processes that shaped not only Pluto, but also the outer reaches of our solar system. The formation of Pluto's moons likely dates back to the chaotic period of the solar system's infancy, when collisions and gravitational interactions were far more common. The presence of multiple moons suggests that Pluto may have experienced a series of impacts, each contributing to the creation of its current satellite system. These moons, along with Pluto itself, are thought to be remnants of the ancient Kuiper Belt, a region filled with icy bodies left over from the solar system's formation. By studying Pluto and its moons, scientists can piece together a clearer picture of how the outer solar system evolved over billions of years. As we delve into the mysteries of Pluto's moons, we're reminded of the dynamic and ever-changing nature of our solar system. These distant, icy worlds hold secrets that can help us understand not only Pluto's history, but also the broader story of how planets and moons form and evolve. And as we continue our journey through the solar system's hidden wonders, the next secret we explore might just reveal another piece of this cosmic puzzle. Next, we'll investigate the Martian methane mystery and its tantalizing implications for the search for life beyond Earth. Now turning to the red planet Mars, we uncover a mystery that has puzzled scientists for decades: the detection of methane in its atmosphere. Methane, a gas often associated with biological processes on Earth, has been sporadically detected on Mars, sparking excitement and debate about the possibility of life on the planet. While methane can also be produced through geological processes, its presence on Mars raises intriguing questions about the planet's past and present habitability. The challenge lies in pinpointing the source of this methane. On Earth, the majority of methane is produced by living organisms, such as microbes in wetlands or the digestive systems of animals. If the methane on Mars has a biological origin, it could suggest the presence of microbial life beneath the planet's surface. However, methane can also be generated through non-biological processes, such as the interaction of water with certain types of rocks or the breakdown of organic material by heat and pressure. Determining the true source of Martian methane is no easy task, as the gas appears in small, fluctuating amounts and is quickly destroyed by the planet's harsh ultraviolet radiation. Adding to the mystery is the irregular pattern of methane detection. Some observations have shown spikes in methane levels, while others have found little to no trace of the gas. This inconsistency has led scientists to hypothesize that methane on Mars might be released in bursts, possibly tied to seasonal changes or geological activity. For example, underground reservoirs of methane could be periodically released through cracks in the planet's surface, creating temporary spikes in the atmosphere. Alternatively, the methane could be produced by ongoing geological processes deep within the planet. The search for the source of Martian methane is a key focus of current and future missions to Mars. Rovers like Curiosity and Perseverance are equipped with instruments designed to analyze the planet's atmosphere and soil for clues. By studying the isotopic composition of methane essentially, the different forms of carbon and hydrogen atoms within the gas, scientists hope to determine whether it has a biological or geological origin. These findings could have profound implications for our understanding of Mars and the potential for life beyond Earth. As we continue to explore the Martian methane mystery, we're reminded of the tantalizing possibility that life, even in its simplest forms, might exist elsewhere in our solar system. Whether the methane on Mars is a sign of ancient microbial life or the result of ongoing geological processes, its detection has opened a new chapter in our quest to understand the red planet. And as we move forward, the next secret we uncover might bring us even closer to answering one of humanity's most profound questions: are we alone in the universe? Next, we'll delve into the origins and fate of Saturn's iconic rings, a feature that has fascinated astronomers for centuries. Now turning to the majestic beauty of Saturn, we find ourselves captivated by one of the most iconic features in our solar system: its dazzling rings. These rings, made up of countless particles of ice and rock, stretch out in a breathtaking display that has fascinated astronomers for centuries. But how did they form, and why are they so prominent compared to the rings of other gas giants? The origins of Saturn's rings remain a topic of debate, but the leading theory suggests they formed from the remnants of a moon or a comet that ventured too close to the planet. The immense gravitational forces of Saturn tore the object apart, scattering its debris into orbit. Over time, this debris settled into the flat, disc-like structure we see today. Another possibility is that the rings are remnants of the primordial material that formed Saturn itself, left over from the early days of the solar system. What makes Saturn's rings so striking is their sheer size and brightness. The rings span an astonishing distance, extending over 280,000 kilometers from the planet's surface. Yet, despite their vast expanse, they are incredibly thin, in some places only about 10 meters thick. The particles within the rings range in size from tiny grains of dust to chunks as large as a house, all reflecting sunlight and creating the brilliant glow that makes Saturn so recognizable. But these rings are not permanent. Scientists estimate that Saturn's rings are slowly disappearing, losing material at a rate that could see them vanish entirely in the next 100 million years. This process, known as ring rain, occurs as the particles in the rings are pulled by Saturn's gravity and fall into the planet's atmosphere where they burn up. Additionally, micrometeoroid impacts and the planet's magnetic field contribute to the erosion of the rings over time. The eventual fate of Saturn's rings serves as a reminder of the dynamic and ever-changing nature of our solar system. As we marvel at their beauty, we're also reminded that even the most stunning cosmic features are temporary, shaped by the forces of gravity, time, and the environment of space. Next, we'll explore the hidden ocean of Europa, a moon of Jupiter that might hold the key to understanding the potential for life beyond Earth. Now turning to the mysteries of Jupiter's moon Europa, we uncover one of the most tantalizing secrets in our solar system, a vast, hidden ocean believed to lie beneath its icy crust. This moon, slightly smaller than Earth's own, has long fascinated scientists because of its potential to harbor life. The surface of Europa is a frozen, cracked landscape, crisscrossed with reddish-brown streaks that hint at the dynamic processes occurring below. But what lies beneath this icy shell could be even more extraordinary. Scientists believe that Europa's subsurface ocean is kept in a liquid state by the immense tidal forces exerted by Jupiter's gravity. As Europa orbits the gas giant, the gravitational pull stretches and compresses the moon, generating enough heat to keep the water from freezing. This ocean is estimated to be over 100 kilometers deep, containing more than twice the volume of all Earth's oceans combined. The presence of liquid water, along with the possibility of hydrothermal vents on the ocean floor, makes Europa a prime candidate in the search for extraterrestrial life. The idea of life on Europa is not just speculation. On Earth, life thrives in some of the most extreme environments, from deep-sea hydrothermal vents to subglacial lakes in Antarctica. If similar conditions exist on Europa, it's possible that microbial life, or even more complex organisms, could exist there. The challenge, of course, is finding a way to explore this hidden ocean. The icy crust, which could be several kilometers thick, presents a formidable barrier, but scientists are already working on solutions. Several missions are planned to investigate Europa further. NASA Europa Clipper, set to launch in the coming years, will conduct detailed reconnaissance of the moon's surface and subsurface. Equipped with advanced instruments, it will map the ice shell, measure the ocean's depth, and search for signs of recent geological activity. Even more ambitious is the concept of a lander or a probe that could drill through the ice to directly sample the ocean below. While this remains a technical challenge, the potential rewards discovering life beyond Earth are too great to ignore. Europa's hidden ocean is a reminder of how much we still have to learn about our solar system. It challenges our understanding of where life can exist and pushes the boundaries of exploration. As we continue to study this enigmatic moon, we may find answers to some of humanity's most profound questions. Next, we'll journey to Uranus's moon Miranda, a world with a surface so bizarre it looks like it was pieced together from different planets. Now turning to Uranus's moon Miranda, we encounter one of the most peculiar landscapes in our solar system. Miranda's surface is a chaotic patchwork of cliffs, valleys, and ridges, giving it the appearance of a world stitched together from fragments of different planets. This small moon, barely 500 kilometers in diameter, is a geological enigma with features that defy easy explanation. The most striking aspect of Miranda's terrain is its sheer diversity. Towering cliffs, some reaching heights of 20 kilometers, plunge into deep canyons, while vast, smooth plains are interrupted by jagged ridges and grooves. One of the most famous features is the Verona Roops, a cliff so steep and high that if you were to drop a rock from the top, it would take nearly 10 minutes to hit the bottom. This chaotic mix of features suggests a violent and dynamic past. Scientists believe that Miranda's bizarre surface may be the result of intense geological activity in its early history. One leading theory is that the Moon was shattered by a massive impact and then reassembled, with its fragments settling into a jumbled, uneven arrangement. Another possibility is that tidal forces from Uranus, similar to those that heat Europa, caused Miranda's interior to melt and churn, leading to repeated episodes of resurfacing. These processes could have created the Moon's patchwork appearance, with different regions representing different stages of its geological evolution. Miranda's chaotic terrain also provides clues about the internal structure of icy moons. The presence of such dramatic features suggests that Miranda's interior was once warm and malleable, allowing for significant movement and deformation. This challenges the traditional view of icy moons as cold, static worlds and highlights the dynamic nature of even the smallest bodies in our solar system. Studying Miranda not only helps us understand its own history, but also sheds light on the processes that shape other moons and planets. Its chaotic surface is a testament to the powerful forces at work in the outer solar system, where gravity, impacts, and internal heat can create landscapes that are as beautiful as they are mysterious. As we continue to explore these distant worlds, Miranda serves as a reminder of the surprises that await us in the farthest reaches of our cosmic neighborhood. Next, we'll venture beyond Neptune to uncover the secrets of the Kuiper Belt, a region filled with icy remnants from the dawn of the solar system. Now turning to the Kuiper Belt, we venture into a distant and icy realm that holds some of the oldest secrets of our solar system. Stretching far beyond the orbit of Neptune, the Kuiper Belt is a vast collection of icy bodies, remnants from the early days of planetary formation. This region is like a cosmic time capsule, preserving clues about how the solar system came to be over 4.5 billion years ago. One of the most fascinating objects in the Kuiper Belt is Arakoth, a small, reddish world that looks like two pancakes stuck together. Arakoth's unique shape and surface provide a glimpse into the processes that built the planets. Scientists believe it formed from the gentle collision of two smaller bodies, a process that likely shaped many of the early building blocks of the solar system. Its smooth, unblemished surface suggests it has remained largely unchanged since its formation, offering a pristine snapshot of the past. The Kuiper Belt is also home to a diverse array of objects, from small icy chunks to dwarf planets like Pluto and Eris. These bodies are thought to be leftovers from the solar system's infancy, material that never coalesced into larger planets. Studying them helps us understand the conditions and forces that shape the planets we see today. For instance, the orbits of some Kuiper Belt objects hint at the gravitational influence of unseen forces, sparking debates about the possible existence of a ninth planet lurking even farther out in the solar system. But the Kuiper Belt isn't just a relic of the past. It's also a dynamic region where collisions and interactions continue to shape its inhabitants. These icy bodies occasionally get nudged into the inner solar system, becoming comets that streak across our skies. The famous Halley's Comet, for example, is thought to have originated in the Kuiper Belt. Exploring the Kuiper Belt is no easy task given its immense distance from Earth. Yet, missions like New Horizons, which flew past Pluto and Arakoth, have provided invaluable insights into this mysterious region. Each discovery brings us closer to understanding the origins of our solar system and the processes that shaped its evolution. As we continue to probe the Kuiper Belt, we uncover not just the history of our cosmic neighborhood, but also the potential for future discoveries. This icy frontier reminds us that even in the farthest reaches of the solar system, there are still secrets waiting to be revealed. Next, we'll journey even farther out to explore the Oort Cloud, a distant shell of icy objects that marks the boundary of the Sun's influence. Now turning to the Oort Cloud, we venture into the outermost reaches of our solar system, a region so distant and mysterious that it feels almost like stepping into another realm. The Oort Cloud is a vast, spherical shell of icy objects that surrounds the Sun far beyond the orbits of the planets and even the Kuiper Belt. Imagine it as a cosmic bubble stretching nearly halfway to the nearest star, filled with trillions of frozen remnants from the solar system's earliest days. This hidden realm is thought to be the birthplace of long-period comets, those spectacular visitors that occasionally streak through our skies. Unlike comets from the Kuiper Belt, which have relatively short orbits, comets from the Oort Cloud can take thousands or even millions of years to complete a single trip around the Sun. When one of these icy bodies is nudged out of its distant orbit by a passing star or the gravitational pull of the Milky Way, it begins a long journey inward, lighting up as it approaches the Sun and becomes visible from Earth. Studying the Oort Cloud is no small feat. Its immense distance, ranging from around 2,000 to as much as 100,000 times the distance between the Earth and the Sun, makes it nearly impossible to observe directly with current technology. Unlike the Kuiper Belt, which we've begun to explore with spacecraft like New Horizons, the Oort Cloud remains a theoretical construct, inferred from the behavior of comets and the orbits of distant objects. This remoteness presents a unique challenge for astronomers who must rely on indirect methods to piece together its structure and composition. Yet, despite these challenges, the Oort Cloud holds immense scientific value. It's believed to be a frozen archive of the solar system's formation, preserving pristine material from over 4.5 billion years ago. By studying the comets that originate here, scientists can gain insights into the conditions and ingredients that existed when the planets were born. Some even speculate that the Oort Cloud could contain interstellar visitors' objects captured from other star systems, offering a glimpse into the wider galaxy. As we ponder the mysteries of the Oort Cloud, we're reminded of just how vast and enigmatic our solar system truly is. This distant shell of icy objects marks the boundary of the Sun's gravitational influence, a frontier that challenges our understanding and fuels our curiosity. Next, we'll delve into another cosmic puzzle, the Sun's missing neutrinos, a mystery that took decades to solve and revealed surprising truths about the heart of our star. Now turning to the Sun's missing neutrinos, we uncover a mystery that puzzled scientists for decades and ultimately reshaped our understanding of both particle physics and the inner workings of our star. Neutrinos are tiny, nearly massless particles produced in vast quantities during nuclear fusion reactions in the Sun's core. They zip through space at nearly the speed of light, passing through matter almost as if it weren't there. In fact, trillions of neutrinos from the Sun are streaming through your body right now, completely unnoticed. For years, scientists detected far fewer neutrinos coming from the Sun than their models predicted. This discrepancy, known as the solar neutrino problem, became one of the most perplexing puzzles in astrophysics. The models of the Sun's core, based on our understanding of nuclear fusion, suggested that a certain number of neutrinos should be produced. Yet, experiments on Earth consistently detected only about 1/3 of that expected number. Where were the missing neutrinos? The breakthrough came when scientists realized that neutrinos have a peculiar property. They can change their identity or flavor as they travel. There are 3 types of neutrinos: electron, muon, and tau, and the detectors on Earth were only designed to capture electron neutrinos, the type produced in the Sun's core. As it turns out, the missing neutrinos weren't missing at all. They had simply transformed into muon and tau neutrinos, which the early detectors couldn't detect. This phenomenon, known as neutrino oscillation, proved that neutrinos have mass, a discovery that fundamentally changed our understanding of particle physics. Solving the solar neutrino problem not only confirmed the accuracy of our models of the Sun's core, but also opened up new avenues of research into the behavior of these elusive particles. It highlighted the intricate dance between the Sun's nuclear processes and the quantum world, showing how even the smallest particles can hold the key to solving some of the universe's biggest mysteries. As we reflect on this groundbreaking discovery, we're reminded of the power of persistence and innovation in science. The solar neutrino problem, once a source of confusion, now stands as a testament to humanity's ability to unravel the secrets of the cosmos. Next, we'll explore another dramatic transformation in our solar system, the vanishing atmosphere of Mars, and how this once habitable world became the barren desert we see today. Now turning to the vanishing atmosphere of Mars, we uncover a story of dramatic transformation that reshaped the red planet from a potentially habitable world into the barren desert we see today. Billions of years ago, Mars likely had a thick atmosphere, complete with flowing rivers, lakes, and even oceans. But over time, this atmosphere began to disappear, leaving behind a cold, dry, and inhospitable landscape. So, what caused this dramatic change? The answer lies in a combination of factors, starting with Mars's weak magnetic field. Unlike Earth, which has a strong, global magnetic field generated by its molten core, Mars lost its magnetic field early in its history. Without this protective shield, the planet became vulnerable to the relentless bombardment of solar winds, streams of charged particles emitted by the Sun. These solar winds stripped away Mars's atmosphere, molecule by molecule, over millions of years. Another key factor was Mars's lower gravity. With only about 38% of Earth's gravitational pull, Mars struggled to hold onto its atmosphere. Lighter gases like hydrogen and helium escaped more easily into space, while heavier molecules were gradually eroded by the solar winds. Over time, this process left Mars with an atmosphere that is less than 1% as dense as Earth's, far too thin to support liquid water or sustain life as we know it. The loss of its atmosphere had profound consequences for Mars. Without the pressure and warmth provided by a thick atmosphere, liquid water could no longer exist on the surface. Rivers dried up, lakes evaporated, and the planet's once promising environment turned into a frozen desert. Today, the only water left on Mars is locked away in ice caps or hidden beneath the surface. This dramatic transformation raises an important question. Could the same fate await Earth? While our planet's strong magnetic field and robust atmosphere offer significant protection, studying Mars serves as a stark reminder of how fragile a planet's habitability can be. By understanding what happened to Mars, we gain valuable insights into the delicate balance that makes a world capable of supporting life. As we leave the story of Mars's lost atmosphere behind, we turn our attention to another fascinating feature of our solar system: the Trojan asteroids of Jupiter, ancient relics that hold clues to the early days of planetary formation. Now turning to the Trojan asteroids of Jupiter, we uncover a fascinating group of ancient objects that share the giant planet's orbit around the Sun. These asteroids, named after the heroes of the Trojan War from Greek mythology, are divided into two groups: the Greeks, which lead Jupiter in its orbit, and the Trojans, which trail behind. Together, they form a unique celestial dance, locked in gravitational harmony with Jupiter at two of the planet's Lagrange points, stable regions where the gravitational forces of Jupiter and the Sun balance perfectly. What makes these asteroids so special is their role as time capsules from the early solar system. Scientists believe the Trojans are remnants of the primordial material that formed the outer planets over 4.5 billion years ago. Unlike many other asteroids which have been altered by collisions or heat, the Trojans have remained relatively unchanged, preserving clues about the conditions and processes that shaped our solar system in its infancy. One of the most intriguing aspects of the Trojan asteroids is their composition. Observations suggest they are rich in organic compounds and water ice, materials that are essential for life as we know it. This has led scientists to speculate that the Trojans might have played a role in delivering water and organic molecules to the inner solar system, potentially contributing to the emergence of life on Earth. Studying these asteroids could help us piece together the story of how our solar system evolved and how life-sustaining ingredients were distributed across it. The Trojans also offer a unique opportunity to explore the dynamics of planetary formation. Their stable orbits and ancient composition make them ideal targets for missions like NASA's Lucy spacecraft, which is set to visit several Trojans in the coming years. By analyzing their structure, composition, and surface features, scientists hope to uncover new insights into how planets like Jupiter formed and how the solar system's architecture came to be. As we delve deeper into the mysteries of the Trojan asteroids, we are reminded of how much there is still to learn about our cosmic neighborhood. These ancient relics not only hold the keys to understanding our past, but also inspire us to keep exploring the wonders of the solar system. With this glimpse into the Trojans, we now shift our focus to another enigmatic feature of our solar system, the magnetic anomalies of Mercury, where strange forces shape the planet's hidden interior. Now turning to the magnetic anomalies of Mercury, we uncover a puzzling feature of the closest planet to the Sun. Unlike Earth, which has a relatively uniform magnetic field, Mercury's magnetic field is patchy and uneven, with some areas exhibiting significantly stronger magnetism than others. This strange phenomenon has left scientists scratching their heads, as it challenges our understanding of how planetary magnetic fields are generated and maintained. One leading theory suggests that Mercury's magnetic anomalies are linked to its unique internal structure. The planet has an unusually large iron core, making up about 85% of its radius. This massive core is thought to be partially molten, creating a dynamo effect that generates the planet's magnetic field. However, the uneven distribution of this magnetism hints at complexities within the core itself. Some scientists propose that variations in the core's composition or temperature could create localized hotspots of stronger magnetic activity, while others suggest that ancient impacts may have disrupted the planet's magnetic field, leaving behind these anomalies. Another intriguing possibility is that Mercury's magnetic anomalies are tied to its surface geology. The planet's crust is rich in iron and other magnetic minerals, which could amplify the magnetic field in certain regions. Observations from NASA's Messenger spacecraft have revealed that some of the strongest magnetic anomalies coincide with large impact basins, such as the Caloris Basin. This has led researchers to speculate that these ancient collisions may have exposed or concentrated magnetic materials, creating the observed variations. Studying Mercury's magnetic anomalies not only sheds light on the planet's interior, but also provides insights into the broader processes that shape planetary magnetic fields. By comparing Mercury's magnetic field to those of other planets, scientists can better understand the diversity of magnetic phenomena in our solar system and beyond. This knowledge could even help us predict the likelihood of magnetic fields on exoplanets, which is a key factor in assessing their potential habitability. As we continue to unravel the mysteries of Mercury's magnetic field, we are reminded of how much there is still to discover about even the most familiar members of our solar system. These anomalies serve as a testament to the complexity and dynamism of planetary interiors, urging us to keep exploring and questioning the forces that shape our cosmic neighborhood. With this glimpse into Mercury's hidden magnetism, we now shift our focus to another enigmatic feature of our solar system, the ghostly rings of Jupiter, where faint structures reveal secrets of the giant planet's past. Now turning to the ghostly rings of Jupiter, we uncover a feature of the solar system that often goes unnoticed. While Saturn's dazzling rings steal the spotlight, Jupiter is also encircled by a faint, ethereal ring system that holds its own secrets. These rings are so subtle that they remained hidden from human eyes until the late 20th century, when the Voyager 1 spacecraft first captured evidence of their existence during its historic flyby in 1979. Unlike Saturn's bright and icy rings, Jupiter's rings are made up of tiny, dark particles, primarily dust and small rocky fragments. These particles are thought to originate from the planet's small inner moons, such as Metis and Adrastea, which are constantly bombarded by micrometeoroids. The impacts kick up debris, which is then pulled into orbit around Jupiter, forming the delicate rings we see today. This process creates a dynamic system, with the rings being continuously replenished as new material is added and older particles spiral into the planet's atmosphere. One of the reasons Jupiter's rings are so difficult to observe is their faintness. They reflect very little sunlight, making them nearly invisible from Earth without the aid of powerful telescopes or spacecraft. Even then, they appear as a thin, hazy band rather than the bold, defined structures of Saturn's rings. This subtlety has made studying them a challenge, requiring advanced instruments and careful observation to piece together their composition and behavior. The discovery of Jupiter's rings has reshaped our understanding of ring systems in the solar system. It shows that rings are not exclusive to Saturn, and that even gas giants with strong gravitational fields can host these delicate structures. By studying Jupiter's rings, scientists gain insights into the processes that shape planetary environments and the interactions between moons, rings, and the planets they orbit. As we peer into the faint glow of Jupiter's rings, we are reminded of the hidden wonders that await discovery in our cosmic backyard. These ghostly structures, though easily overlooked, offer a glimpse into the complex and dynamic nature of our solar system. With this exploration of Jupiter's rings complete, we now turn our attention to another intriguing mystery: the mysterious bright spots on Ceres, where a dwarf planet holds clues to the early history of our solar system. Now turning to the mysterious bright spots on Ceres, we delve into one of the most puzzling features of this dwarf planet. When NASA's Dawn spacecraft first captured images of Ceres in 2015, it revealed a series of strikingly bright spots scattered across its surface, particularly within the Oort crater. These spots, gleaming against the otherwise dark and rocky terrain, immediately sparked curiosity and speculation. Some even wondered if they could be signs of alien activity or artificial structures. However, as scientists analyzed the data, a more grounded yet fascinating explanation emerged. The bright spots are now believed to be deposits of sodium carbonate, a type of salt mixed with other minerals. These deposits likely formed when briny water from beneath Ceres' surface rose to the top and evaporated, leaving behind the reflective salts. This process suggests that Ceres may have, or once had, a subsurface reservoir of liquid water. The presence of these salts points to a history of hydrothermal activity, where heat and water interacted to create the conditions necessary for such deposits to form. This discovery has profound implications for our understanding of Ceres and its potential to harbor, or have harbored, the ingredients for life. What makes these bright spots even more intriguing is their persistence. Unlike other features on Ceres, which may fade or change over time, the spots in Oort crater remain strikingly bright, even as the dwarf planet orbits the Sun. This suggests that the process creating them is ongoing, with briny water possibly still seeping to the surface in some form. The Dawn spacecraft's detailed observations also revealed a haze that occasionally forms above the crater, further supporting the idea of active processes at work. The discovery of these bright spots has reshaped our view of Ceres, transforming it from a seemingly inert, rocky body into a dynamic world with a complex geological history. It challenges our assumptions about dwarf planets and their potential to host conditions that could support life. As we continue to study Ceres, these bright spots serve as a reminder of the surprises that await us in the outer reaches of our solar system. With this mystery of Ceres now illuminated, we prepare to explore another enigmatic visitor to our cosmic neighborhood, the interstellar object known as Oumuamua. Now turning to the interstellar visitor known as Oumuamua, we encounter one of the most extraordinary objects ever observed in our solar system. Discovered in October 2017, Oumuamua became the first known interstellar object to pass through our cosmic neighborhood, originating from beyond our solar system. Its name, which means scout or messenger in Hawaiian, reflects its role as a harbinger of the mysteries that lie in the vastness of interstellar space. What immediately set Oumuamua apart was its unusual shape. Unlike most asteroids or comets, which are roughly spherical or irregular, Oumuamua appeared to be elongated, resembling a cigar or a pancake. Estimates suggest it could be up to 10 times longer than it is wide, a shape never before seen in natural objects within our solar system. This bizarre form sparked intense curiosity and debate among scientists and the public alike. Adding to the intrigue was Oumuamua's trajectory. As it sped through our solar system, it exhibited unexpected acceleration, deviating from the path predicted by gravity alone. This behavior led to speculation about its composition and origin. Some scientists proposed that it might be a comet with outgassing material causing the acceleration, but no visible coma or tail was observed. Others suggested it could be a fragment of a larger object shattered by a cosmic collision. The most tantalizing possibility, however, was that Oumuamua might not be a natural object at all. Its unusual shape, trajectory, and lack of visible outgassing led some to speculate that it could be an artificial construct, perhaps a piece of alien technology or even a spacecraft. While this idea captured the public's imagination, most scientists remained skeptical, emphasizing the need for more data to draw definitive conclusions. Despite the debates, Oumuamua's brief visit provided invaluable insights. It offered a glimpse into the diversity of objects that travel between star systems, challenging our understanding of how such bodies form and behave. As it sped away, leaving our solar system behind, Oumuamua left us with more questions than answers, a reminder of how much we still have to learn about the universe beyond our own cosmic backyard. With the mystery of Oumuamua still lingering, we now turn our attention to another hidden treasure within our solar system, the discovery of water ice on the Moon and what it means for the future of lunar exploration. Now turning to the Moon, we uncover one of the most exciting discoveries in recent lunar exploration, the presence of hidden water ice. For decades, the Moon was thought to be a dry, barren world, but groundbreaking observations have revealed that water ice exists in its permanently shadowed craters, particularly near the poles. These regions, shielded from the sun's heat, act as natural freezers, preserving water that may have been delivered by comets or formed through interactions with solar wind over billions of years. The discovery of lunar water is a game-changer for future space exploration. Water is not only essential for human survival, but can also be split into hydrogen and oxygen, providing breathable air and rocket fuel. This means that the Moon could serve as a crucial stepping stone for missions deeper into the solar system, reducing the need to transport resources from Earth. Imagine a future where lunar bases harvest water to support astronauts and refuel spacecraft, turning the Moon into a cosmic gas station. But the presence of water also tells us something profound about the Moon's history. It suggests that the Moon has been a more dynamic and resource-rich body than we once believed. The water ice in its craters could hold clues about the early solar system, including the materials that formed Earth and its Moon. By studying this ice, scientists hope to piece together the story of how water, a key ingredient for life, became distributed across our cosmic neighborhood. As we look to the future, the Moon's hidden water opens up incredible possibilities. It not only supports the dream of sustainable lunar exploration, but also deepens our understanding of the Moon's past and its connection to Earth. With plans for new missions to the lunar surface, including NASA's Artemis program, the secrets of the Moon's water are poised to unlock a new era of discovery. With this newfound knowledge of the Moon's hidden treasures, we now turn our gaze to the outer reaches of the solar system, where the strange orbits of exoplanets challenge everything we thought we knew about planetary systems. Now turning to the strange and fascinating world of exoplanets, we uncover a realm where the rules of planetary motion seem to bend and twist in ways that defy our expectations. Among the thousands of exoplanets discovered beyond our solar system, some exhibit orbits so bizarre that they challenge everything we thought we knew about how planets form and behave. Take, for example, the exoplanets that orbit their stars backward. Unlike the orderly, counterclockwise motion of planets in our solar system, these worlds move in the opposite direction, defying the natural rotation of their parent stars. Scientists believe this backward motion, known as a retrograde orbit, could be the result of gravitational interactions with other planets or passing stars, which flung these worlds into their unusual path. This discovery forces us to rethink the stability and predictability of planetary systems. Then there are the exoplanets that are tidally locked to their stars, meaning one side of the planet always faces the star while the other remains in perpetual darkness. Imagine a world where one hemisphere is scorched by eternal daylight, while the other is frozen in endless night. These extreme conditions create environments unlike anything we see in our solar system, with potential implications for the possibility of life. Could life exist in the twilight zone between these two extremes? It's a question that continues to intrigue scientists. These strange orbits not only challenge our understanding of planetary formation, but also reveal the incredible diversity of worlds that exist beyond our solar system. They remind us that the universe is far more complex and unpredictable than we once imagined. As we continue to discover more exoplanets, each with its own unique characteristics, we are forced to expand our theories and adapt our understanding of how planetary systems evolve. With these discoveries in mind, we are left to wonder what other surprises the cosmos holds. As we prepare to explore the final secret of our solar system, the possibility of a hidden ninth planet lurking in the outer reaches, we are reminded that the universe is full of mysteries waiting to be uncovered. Now turning to the final mystery of our solar system, we delve into the tantalizing hypothesis of a ninth planet lurking in the distant outer reaches. This elusive world, often referred to as Planet 9, is believed to be a massive object, possibly 10 times the size of Earth, orbiting far beyond Neptune. The idea of a hidden planet was first proposed when astronomers noticed peculiar patterns in the orbits of smaller objects in the Kuiper Belt, a region filled with icy bodies beyond Neptune. These objects seemed to be clustered in a way that suggested the gravitational influence of a much larger, unseen planet. The evidence for Planet 9 is indirect but compelling. Mathematical models and simulations show that the gravitational pull of such a planet could explain the unusual orbits of these distant objects. However, detecting this hypothetical world is no easy task. Its extreme distance from the Sun means it would reflect very little light, making it incredibly faint and difficult to spot with even the most advanced telescopes. Additionally, its slow orbit, estimated to take between 10,000 and 20,000 years to complete, means it could be almost anywhere along its vast path. The search for Planet 9 has sparked excitement and debate among scientists. If it exists, this planet could reshape our understanding of the solar system's formation and evolution. It might even provide clues about the early history of our cosmic neighborhood, offering insights into how giant planets migrate and interact over billions of years. Some researchers speculate that Planet 9 could be a captured rogue planet, originally from another star system, adding another layer of intrigue to its story. As we continue to scan the skies for this hidden giant, the possibility of its discovery reminds us that our solar system is still full of surprises. Whether or not Planet 9 is found, the search itself pushes the boundaries of our knowledge and technology, proving that even in our own cosmic backyard, there are still secrets waiting to be uncovered. And with that, we conclude our journey through the 25 hidden secrets of the solar system, each one a testament to the wonder and complexity of the universe we call home. Now turning to the conclusion of our cosmic journey, let's take a moment to reflect on the 25 hidden secrets we've uncovered in our solar system. From the hexagonal storm on Saturn to the icy geysers of Enceladus, and from the diamond rain on Neptune to the mysterious planet 9, each discovery has revealed just how intricate and enigmatic our cosmic neighborhood truly is. These secrets remind us that even in the vastness of space, there are countless wonders waiting to be explored and understood. The solar system is far more than a collection of planets and moons. It's a dynamic, ever-evolving system filled with surprises that challenge our understanding of the universe. Whether it's the hidden oceans beneath icy crusts, the bizarre orbits of distant objects, or the lingering mysteries of ancient collisions, each secret invites us to ask deeper questions and seek new answers. These discoveries not only expand our knowledge but also ignite our curiosity, reminding us that there's always more to learn. As we wrap up this exploration, we'd love to hear from you. Which of these 25 secrets fascinated you the most? Was it the possibility of life on Europa, the strange tilt of Uranus, or the enigmatic planet 9? Share your thoughts in the comments below. We're excited to hear your perspectives and continue the conversation. And if you enjoyed this journey through the mysteries of our solar system, don't forget to subscribe and hit the notification bell so you never miss out on our next cosmic adventure. Together, let's keep uncovering the wonders of the universe, one secret at a time.